Student, welcome to the physics class. Today in this video we are going to cover chapter 1, electric charges and field. So in this chapter we will cover two topics. The first name is introduction of electric charge and its basic properties. The second topic is difference between mass and charge. So let's start. So first of all, what is electric charge? Charge is an intrinsic property of a matter due to which matter experiences force. So what does it mean by intrinsic? Intrinsic means independent. So charge is an independent property. It does not depend on the other things. So basically, electric charge is a property of matter due to which it experiences force on the other matter particles. So let us consider example. In this example, you can see here we have a glass rod. This is our glass rod, and we have a silk cloth. This is our silk cloth. So what we will do, we will bring a glass rod near to the silk cloth and we will rub the two things. After rubbing, you will get some charges on the glass rod and the silk cloth. This is our first case. Now similarly we will bring another glass rod and we will rub this glass rod with the silk cloth. So what will happen? Due to rubbing, the glass rod will get some charge and silk cloth will also get some charge. So now in the third step, this is our first step, we will charge a glass rod. First glass rod we will charge with the help of silk cloth. Similarly, we will charge a second rod with the silk cloth. Now in the third step, we will bring these two charged rods near to each other. So what we will observe, you will see these two rods will show repulsion. They will repel each other. So this is the property of the charge. That's why according to the definition, charge is an intrinsic property of matter due to which matter experiences a force. So these glass rods experience a force on each other. Here that force is a repulsive force, right? Similarly, if we have a one positive charged rod and other one is a negatively charged rod, so what will happen? These will feel force of attraction toward each other. So in this way we can understand electric charge is a property of matter due to which matter experience a force of attraction or repulsion. Now next, we know there are two kind of charge. One is positive and the other one is negative. Basically, charges were discovered by a American scientist Benjamin Franklin. Benjamin Franklin was a American scientist, and he discovered charges in 18th century. Okay, and positive and negative charge named is given by Benjamin Franklin. We are used to say there are two kind of charge, positive and negative charge. So these two named were given by Benjamin Franklin. That was a American scientist. So now what is the SI unit of charge? The SI unit of charge is coulomb. COULOMB, coulomb, and the symbol is C. And what is the dimension formula? Dimension formula for charges is AT. How it is AT? A is current ampere. We know Q is equal to IT. What is current? Current is rate of flow of charges. So here we know the dimension of current is A and dimension of time is T. So now the dimension formula is AT. Next, we will discuss the properties of charges. So first property is additivity of charge. So additivity of charge means we can add charges algebraically. For example, in a system we have three charges. First one is Q1 charges having value minus 3 microcoulomb, Q2 charges having value 2 microcoulomb, and Q3 charge having value 5 microcoulomb. So now what will be the total charge of the system? So total charge of the system we can calculate by adding all the three charges, charge 1, 2 and 3. So what is the value of first charge? -3, Q2 is 2, Q3 is 5. So after adding, what will you get? 5 plus 2 7, 7 minus 3 is 4. So total charge on the system is 4. So you can see here we added the charges algebraically. So charges follow the algebraic sum of charges in different region of the body. Next we will discuss the conservation of charge. Yeah, the second property is conservation of charge. According to the definition of conservation of charge, the net charge of an isolated system remain constant or conserved. So let us understand this thing. Let us consider we have an isolated system. So now what is isolated system? Isolated system is that system where there is no external thing can enter or external force can enter. So let us consider this box. There are three charges, 3 coulomb, 2 coulomb and 1 coulomb, and there is no external force from the outside. For example, if you lock yourself inside a door and you are not allowed to go outside or take anything from inside or outside, means everything is banned. So now you are in a isolated system. So same condition is there on charges. This is your isolated system. These charges cannot experience any external force, but they can interact with each other. So now initially we have three charges which are isolated from the external system, but they can interact with each other. So after interaction, what will happen? Now they are interacted because positive and negative attract each other, positive repel, and all these things will happen. So now after interaction, what will happen? After interaction, let the charges will remain the same, but suppose now we have 1 coulomb. After interaction we have these charges left. So now count the charges. Here 3 and 1, this is your 2 coulomb charge, not negative, this is 2 coulomb charge. Here charge is 2 coulomb. 3 2 5 1 6. So initially the total charge of the system was 6 coulomb. Now after interaction they repel, they interact with each other and all. So what is the final result? 3 4 7 and 7 minus 1. So again it remain 6 coulomb. So what we observed from here, we observed in an isolated system the charge before interaction and after interaction will remain same. Here also charge is 6 coulomb. So that's why we call, when there is no external force on the system, the total charge before interaction and after interaction will remain the same. Now we will take some more example based on the conservation of the charge. So now first example I will take, that is pair production. Pair production, from the name it is clear, pair will produce, some particle will produce. So I will take one example. Let us consider the total charge of a system is 0. So I will take example of a light, photon. Photon is a form of light energy. So let us consider we have a photon, this ray, electromagnetic ray, and this ray strike with a nucleus. This is nucleus of any atom. So when a photon strike with the nucleus, so after strike the photon will divide into two parts, in two pair. So one will be positive, that is known as positron, and the second will be electron. These are antiparticle, both are antiparticle. The charge on the electron is negative and the charge on the positron is positive, one charge. So but what is the charge on the photon? The charge on the photon is 0. So now check, before collision, before striking, what was the charge? 0. And after collision, it get divided into two parts. One is positron and the other one is the electron. Both are antiparticle. So what is the charge on electron? Positive 1. What is the charge on electron? Negative 1. So what is the charge? Again it is 0. So before interaction and after interaction, charges are 0. So this shows the conservation of the electric charge. Okay, so this is the first example. Now we'll take more example for deep knowledge. So now the next example is pair annihilation. From the name pair annihilation. Annihilation means destroy, to destroy something, annihilation. So in this case, again we will take the example of positron and the electron. What are positron? These are all elementary particle like electron. So here we have E negative. This is your electron. Sorry, this is electron, and this is positron. So both are antiparticle. So how they will interact? When they will interact, so again a photon, a ray energy will release. So charge on it. Now we will compare again. Negative charge, here positive charge, and we know the photon the photon charge is 0. Rest mass is also 0 and charge on the photon also 0. So now again this condition satisfied and we can say charge is conserved. Okay, so now next thing we will discuss, one more example we'll take. After that we will do the next property. So this is pair annihilation. These two pairs destroy each other and produce a light, that is photon. So in this case charge is again conserved. And third example we can take uranium example. In a chain reaction we have a heavy element that is known as radioactive element uranium. The mass of uranium is 238 and the atomic number is 92. So now what will happen when it will interact with a neutron? When a neutron is strike on the nucleus of a uranium atom, so it will divide itself into two parts. First element is thorium and the second one is helium. So what is the thorium mass number? That is 234 and 90 is the atomic number, and for helium it is 4 and 2. So now see again, as we know the atomic number is based on the charge on the proton. So number of protons are 92. So now the total number of charge is 92 in this case, and this one having charge 90 and this one 2. So again 92 is equal to 92. It remain constant. It means charge is conserved. So these are the example of conservation of charges. Now we are going to discuss the third property, that is quantization of charge. So what do you mean by quantization of charge? We will understand. The basic property of the charge is quantization of charge. I will give you some example of quantization of charge, but before that you have to understand what is quantization. Quantization means something in a discrete amount like 1, 2, 3. That is not continuous. For example, rice at your home, you have rice, the pulses and all these things. So rice are in the discrete form, 1 rice, 2 rice, like that. So similarly charge exists in the discrete amount. When a charge enter from one body to the another body, so it will always enter in the number 1 charge, 2 charge, 3 charge. It will not enter like 1.5 charge will enter, 1.2 charge will enter, 1.3 charge will enter. For example, if you want to purchase some apple, so you will buy the apple in the form 1 apple, 2 apple, 3 apple, like that. your shopkeeper will not give you one half apple or one and one point half apple. That thing is not possible. So similarly, charge always enter from one body to the another body in discrete amount, like one charge will enter 2, 3, 4 and 5, like that. So because of that, we will say charge is not a continuous property, it is a discrete property, and we can write discrete property in this form, that is q is equal to plus minus ne. What is e? E is the basic property of charge, that is your basic unit of charge. Basic unit of charge, that is your charge on electron, that is 1.6 into 10 raised to power minus 19 coulomb. And what is n? N is integer number, it may be plus minus 1, 2, 3, like that. So always charge will enter one by one. One charge, one electron can enter, two electron can enter. So in general term we can write q is equal to plus minus ne. Okay, so you can say charge cannot exist in real number like 1.5, 1.2. Charge exists in the integral number. And the smallest charge that can exist independently is the charge on the one electron. The smallest charge which can exist independently. So for your previous knowledge, you know, the charge is the charge on the electron, and electron is the smallest thing which exists inside the nucleus. But this is not true. Except electron, there are so many elementary particle which exist inside the nucleus, but this particle does not exist independently, like your proton. So proton is a combination of small particle. Proton, there are very small particle than proton, that is known as elementary particle. There are 24 elementary particles. This is in your higher classes you will study, but I will give you some brief. Okay, so charge on the electron is the smallest independent unit, but there are some other very small particle exist. So we will discuss this particle proton, and we will take the example of proton and neutron. So there are so many particle, that is elementary particle, that is up, down. The name of these part, like electron, proton and neutron, there are some other particles, the name is up, down, charm, strange, top and bottom. And these particles have charge. That charge is smaller than the charge of electron. Plus 2e by 3 on this one. Here charge is minus 1 by 3e. Positive 2e by 3 on charm, minus e by 3, plus 2e by 3 and minus e by 3. But all these elementary particle does not exist independently, but electron can exist independent, but these particles cannot exist independently. They will always exist in groups. So for example, we will take example of proton. In proton is formed due to the combination of up particle. We will represent up by u. Up, two up particle, and one is down. So now what is charge on up particle? 2 by 3e. 2 by 3e positive. And for 2 by 3e, and on the down particle it is minus 1 e by 3. So now what is the overall charge if you added all these charges? 2 by 3, I will take e common, just a minute. E is common in all, or simply you have to take the LCM, nothing else. 2 by 3 plus 2 by 3, and this is minus 1 by 3. So what will happen? This will be 4 by 3 and this one is 1 by 3. So this will be 3 by 3. This is your, so you get E here. So now this is positive E. So this is the charge on proton. The charge on proton is positive 1. So overall sum of all these charges is also positive. Okay, so proton is the combination of the smaller and elementary particle. These, so you can say there are small charges exist in the universe which are smaller than the electron, but these charges are exist together. They are not existing independently. So that's why we say the smallest charge that can exist independently is the charge on electron, because charge on electron exists independently, but a charge on up, down, charm, strange, top and bottom does not exist independently. They always exist in the collection. Similarly, you can do for neutron. So neutron is a combination of down, down and up. So charge on down is, you can write it minus E by 3 minus E by 3, and for U it is 2 E by 3. If you add all these, you will get 0. The net charge of all the 3 is 0, and we know the charge on the neutron is 0. So this is the quantization of charge, and the smallest charge that can exist independently is your charge on electron, that is 1.6 into 10 raised to power minus 19. That's why we multiply here. Q is equal to Ne, plus means electron positive, positron and electron both can be there, and it is multiplied by the basic unit. So smallest basic unit of charge is electron, and the charge on electron is 1.6 into 10 raised to power minus 19. So now we will come to the next property, that is invariance of electric charge. Now the fourth property is invariance of electric charge. Charge on an object independent of the speed of the object, means charge does not depend on the speed of the object. For example, if you are moving in a car and you have some charged particle, so the car speed is going to increase, but your charge particle speed will not increase. It means charges at rest or charges in motion, in both case charge will remain same. Okay, so we'll take one example. Let us consider we have an atom, and we know inside the atom nucleus is there, and electrons are moving around the nucleus in certain selected path. Okay, so now, and we know this atom is electrically neutral. So atom is neutral, there is no charge on atom electrically. So this thing is a proof thing. So if, and we also know the electrons are always move around the nucleus, and that is in the motion. So electron always gain energy when it is in a motion. So if it is in motion, so what will happen? Suppose it gain charge. If it gain charge, so what will happen? So because there is a equal number of positive and negative charge on the atom, if it gain charge, so atom will not remain stable, not remain neutral. So that's why we can say there is no effect of motion on the charge. If is there any effect of motion on the charge, then atom will not remain neutral. If this electron during motion gains some charge, so overall atom will not remain neutral. Okay, so that's why we can say invariance of electric charge on an object independent of the speed of the object. So charge does not depend on the speed of the object. That is our fourth property of the charge. Now we will discuss difference between mass and charge. So first of all, this side we will take mass and this side we will take charge. Mass is a positive quantity. We will take mass as a positive. Charge can be negative and positive. This is the first difference. Both are intrinsic property. The main property of mass and charge which I want to discuss is, rest of all you can get from anywhere, but the two properties which is very important I want to discuss. So first one is positive and negative. The charge positive charge is positive and negative, and mass is always positive. We cannot take the mass minus 5 kg mass minus 5 kg thing we want. So this is always positive. Next one is charge do not vary with speed. We discussed in the invariance of charge. Charge do not vary with speed. We discussed this thing in the invariance property of charge. Okay, now what about sorry, this thing is for charge. So charge do not vary with speed. Do not vary with speed. What will happen in case of mass? So mass varies with speed. There is a major difference. Mass varies with speed according to this relation. M is equal to m naught 1 minus v square by c square. So now what is v here? V is the speed of body. Speed of body of mass m. So what is v here? This v is the speed of the body having mass m. M naught is rest mass. When body is at rest, when body is at rest. So m naught is the mass when body is at rest. V is the speed of the body having mass, this one m, and c is the speed of light. So now we will discuss how it will affect. Now I will discuss only this relation, that is the most important relation. So here what will happen? And now the question is why mass variation we cannot observe in our daily life. If you see, when you are moving, you are in a motion, you are running, so what will happen? You're during jogging, walking, your mass is not varying. We observe our mass is not varying, but actually according to this relation, when body is in a motion, the mass should increase. But this thing we cannot observe in daily life phenomena because our speed is very slow. Speed means v is very low. This v should be comparable to the speed of the light. Speed of light is very high, but our walking speed and running speed, that is very low. So our mass increases, but that is not noticeable. If you remember this equation, Einstein equation, E is equal to mc square. So according to this relation, your mass is equal to, you can write E by c square. So when you are in a motion, what will happen? Your body will get heat, and that is also energy. So during motion, your mass is increased in the form of energy, in the form of kinetic energy. When you are walking, kinetic energy is there, and little bit your body get warm. So that time your body mass is converted into energy, kinetic energy plus heat energy. So that change is very small, so we cannot observe that change in the daily life. But what will happen then when body v is moving with a very high speed? Like, let that speed is equal to the, we will take example now, let the body speed is half of the speed of light. Then what will happen? Now substitute the value in this relation, 1 minus, now the v is c by 2 whole square by c square. If you solve this relation, c square cancel, and here 2 to the 4, So you will get this thing, c square will cancel and this 4 will come, so 1 minus 1 by 4, and you will get after solving this thing. So you can see, you can compare this m and this m naught. Now the mass is increased by 2 by root 3 time of m naught. Initially mass was m naught, but when the speed of body is increased very high, that is almost half of the speed of the light, so in that case overall the mass of body is increased by 2 by root 3 m naught. So it means the mass of body increases when the speed of the body increase, but in daily life application this increment is very small, so we cannot notice it. But when a body moves with a very high speed, that is almost near to the speed of light, or half or quarter of the speed of the light, so in that case the mass will increase and that is noticeable. So these two are the basic property of the mass and charge, and this property is very important. I discussed only two property, rest of the property are very easy, you can refer any book for this property. So I hope I am able to teach you in a better manner today. So if you like my video and this lecture, so for more updates and for the next lecture, subscribe my channel. Thank you, students.